Hi everybody, Mr. Bainey here. Thank you for watching my videos. This is lesson 1.2, Set of Real Numbers. The essential question is how can you describe relationships between sets of real numbers? And the standard, I'm not going to read this whole thing here, but it's up in the top right, 8.ns.1. So real numbers, what are these things called real numbers? Something that we're going to be working with all year. So we're going to use an analogy or think of an analogy that we can classify things like animals. We can really classify anything that we want to in the world. But things that are called animals, we can break down into smaller groups. And so you can break them down into vertebrates, and then birds are a part of that, right? So not all birds are vertebrates. And then there's different types of birds. So we can break that down into even a smaller group called these passerines. So these are birds, but they're also vertebrates and they're also animals. Okay, so these passerines belong to all of these groups, right? All of these bigger groups. So we're going to classify numbers in a very similar way. So we're going to start off with something called the whole numbers. Okay, up here, I'm going to actually add to some of these notes. So the whole numbers also contain the numbers that we count with, really. So 0, 1, I'm sorry, it doesn't contain 0. So oh, it does. I'm sorry, there is a smaller group that we also deal with called the natural numbers. But the whole numbers starts with 0, and then the numbers we count with, 1, 2, 3, 4, and so on, right? I'm going to put the dot, dot, dot here. So you might think, why is square root of 4 a whole number? Well, remember the square root of 4 is equal to 2, and 2 is a whole number. So that makes the square root of 4 a whole number. Now integers are going to contain whole numbers and also the negatives. So it's going to be something like -3, -2, -1, 0, 1, 2, and 3, and dot, dot, dot. I'm going to put also dot, dot, dot on this left side because it keeps going in a negative direction and keeps going in the positive direction. Okay, so you can see that a number like 2 is in both of these, right? So 2 is a whole number. 2 is also an integer. And we go up here, 2 is also rational, and 2 is also a real number. So 2 is all of these things. Okay? It's not irrational, though, over here on this side because it's not connected to it. The rational numbers are going to contain, let's see if I can fit this in here somewhere. It's going to contain terminating decimals. It's also going to contain repeating decimals. They don't give us a lot of space here, so I'm just writing it where I can. Repeating decimals. And it's also a fraction. I'm going to write this on the right side. It's also a fraction, but the bottom cannot be 0. The technical term is denominator. So it's a fraction. The top and the bottom of a fraction have to be integers. The bottom cannot be 0 because that would be undefined, right? If you try to put that in your calculator, you can't do it. Irrational numbers are numbers that are square roots. So you'll see a bunch of square roots here. So square root of 17, square root of 2, square root of 11, where the number inside is not a perfect square. Like you can't take the square root of 17 very easily, or the square root of 2 very easily, or the negative square root of 11 very easily. So those are irrational. And also something like pi, what you see at the bottom. So these are non-terminating and non-repeating. If you remember what pi looks like, it is a decimal that goes on forever. It does not repeat, so it doesn't terminate, non-terminating, and non-repeating decimal. So our main goal for today is just to figure out what kinds of numbers, what kinds of sets do these numbers belong in. Okay, so let's take a look at some examples. Please refer to this as you're trying some of these out for yourself. Okay. On the next page, we have this your turn at the top. We're going to write all the names that apply to these numbers. So number 1, a baseball pitcher has pitched 12 and 2/3 innings. So I see a fraction with 2 integers, a 2 on the top and a 3 on the bottom. So this is going to be a rational number, right? You start from the inside of your diagram that we just worked on. You ask, is it a whole number? Nope, it's not. Is it an integer? Nope. Is it rational? And it's yes. Is it real? That's also a yes. So it's both of those. Okay. And number 2, the length of the side of a square that has an area of 10 square yards. So is that a whole number? Yes, it is. Is it an integer? Yes. Is it rational? Yes. And is it real? That is a yes. So what you see here is that if it's a whole number, it's everything outside of the whole number. So it's all of the other sets or groups. If it's rational, it's always going to be a real number. Okay, so let's take a look at some more examples. Where you want to determine if these statements are true or false and explain your choice. So think very deeply about what these groups that we've looked at already, what they mean, and how they're related to each other. So number 3, all rational numbers are integers. So are all of them. So think about a rational number, right? It could be a fraction, it could be a terminating decimal, it could be a repeating decimal. Could be some of those. So are those integers? And the answer is no, that's false. And we want to explain this. So some rational numbers are integers. So think of a rational number that is an integer and think of one that isn't. So something like 1/2 is not an integer, but it is rational. And then something like -4. -4 is an integer. It's also rational, right? So it is rational and it is an integer. And I can come up with a lot more, but this is just to make that point, that not all rational numbers are integers. Okay, and number 4, some irrational numbers are integers. So think about irrational. It's a non-terminating, non-repeating decimal. It's the square root of these non-perfect squares, right? Not easy to take the square root of. And so this is also going to be false. Because something like pi, or like the square root of 11, these are not integers. Right? Integers are not really connected to our set of irrational number. And so these are not integers. Sorry, I forgot to add this word "and" here. If you would like to look at a couple more examples of how you're thinking about these sets, read parts A and B just right above. Okay, and the last type of example we have here is, we'll just go straight to the your turn. Read these examples right here if you want to get some more types of examples. But we want to identify the set of numbers that best describes the situation. Okay, so what type of number, what set of number are we going to be looking at? So number 5, the amount of water in a glass as it evaporates. So the amount of water, we want to think about what kind of number am I going to see here. We can measure this in things like ounces, right? Cubic inches, so anything that represents like a volume, the amount of space that it's taking up. So could that be a whole number? Could I have, like, let's say like 5 ounces left? Yeah, I could. Could it be an integer? So negatives, does that make sense? I can't have a negative amount left. It could be rational though, like I could have 2.5 ounces left. And it's going to be real as well though. These are all real numbers anyway. So thinking about just all the types of numbers, we can't have negative, but we can have rational. And irrational, it could be irrational, although we wouldn't normally use irrational numbers to describe the amount of water left. So we're going to say whole number. But all whole numbers are integers. I'm going to include integers, but no negatives, right? That wouldn't make sense here. And then also rational numbers, which these are all real numbers. So we could use real numbers for these. Number 6, the weight of a person in pounds. And so the weight of a person, if you were to tell me your weight, if I tell you my weight, what kind of number would that be? So that could definitely be a whole number. So I could say something like, I weigh 150 pounds. Integers, I could use some integers, but this is similar to number 5. I cannot say I weigh negative 20 pounds or something like that, right? So we don't want to think about negatives here. And then I could also use rational numbers, because I could say, oh, I weigh about 155.5 pounds, and these are all real numbers. Okay, and that is it for this lesson. Thank you so much for watching. Have a good day.